Have you ever been scrolling through your social feed and you just wonder, how does it know exactly what to show you next? Or maybe you've pulled up a map and it finds the fastest route in like 2 seconds flat. Well, I can tell you, it is not magic. It's all about the hidden architecture of code that's running everything. So today, we're going to dive right in and explore the absolute fundamental building blocks of our digital world: data structures and algorithms. And to help us out, we're going to be using this fantastic book as our map, the 6th edition of Data Structures and Algorithms in Java. You can just think of this as our expert guide, the thing that's going to help us understand the core principles that make pretty much the entire digital world tick.
So really, what is the secret? How does that social feed load so quickly? How does a GPS figure out the best route, instantly? Well, the answer comes down to something pretty simple in theory: the clever and, most importantly, efficient organization of data. It's all about choosing the right tool for the right job.
Yeah, and this isn't some niche topic just for a handful of experts. As our book points out, this is a core subject in all of computing. And why is that? Well, because everything from your computer's operating system to huge databases to the web itself, it all depends on this stuff. Efficient data structures are what separate a fast, snappy system from a slow, frustrating one. This is the bedrock.
Okay, so to actually build any of these things, we need a language, right? We need a way to give the computer instructions. The book we're using is all about Java, so that's going to be our language for this explainer. You can think of it as the toolbox we're going to use to construct all the cool systems we're about to explore.
Now, the book kind of assumes we're already comfortable with the basics of programming. The fundamentals you'd find in just about any language. Stuff like variables, methods, if statements, and for loops. If you've ever written a bit of code before, these concepts are probably old friends. They're our starting point. Everything else gets built on top of them.
All right, our first major concept is one of the most powerful ideas in all of modern programming. Think about it. If you want to build something complex, like a house, you don't just show up and start throwing bricks together, right? No, you start with a plan, a blueprint. Well, in the world of code, that blueprint is called a class.
So here's the crucial idea. A class isn't the house itself. Not at all. It is the plan that describes what a house is. It says a house is going to have a certain number of rooms, that's its data, and that you can do certain things like open a door or turn on a light. Those are its methods or its actions.
Let's make this whole blueprint idea a little more real. Here's a super simple example right from the book, a class called counter. This blueprint lays out 2 things. First, any counter we build from this plan will have a piece of private data tucked away inside it, an integer to hold the count. And second, it defines 2 public actions you can perform. You can increment it to add 1, and you can get count to ask it what its current value is.
But a blueprint is just a plan on paper, right? It's not really useful until you actually build something with it. In programming, when we take a class and use it to build a real working thing in the computer's memory, we create what's called an object.
So, an object is what we call an instance of a class. If the counter class is the blueprint for a click counter, then an object is a real working click counter that actually exists. What's cool is you can build as many of these as you want from that one blueprint, and each one will keep track of its own totally separate count.
And this is how we do it. This one line of code is basically the order you give to the construction crew. That new keyword is the magic word. It tells the computer, hey, take that counter blueprint, go build me one, and then give me a way to talk to it. And that way to talk to it gets stored in our variable, C.
This brings us to a really important distinction. See, simple variables like an int, they store a value directly. The box literally holds the number 5. But object variables, what we call reference types, are different. They don't hold the object itself. Instead, they hold the address of where that object is living in the computer's memory.
And the book uses this absolutely brilliant analogy to explain it. Think of the object you created as the TV. Your variable C, well, it's not the TV itself. It's the remote control. It just holds the signal, the reference, that lets you interact with the actual TV object. You could even have multiple remotes, just like the book shows, all pointing to and controlling that same one TV.
So, how do we actually use this remote control? With the dot operator, that little period. When you type c.increment, it's like you're pushing a button on the remote. It sends a signal over to the counter object and tells it, hey, run your increment method, which then increases its internal count. And c.getCount is like pressing another button that asks the object, what's your current value? And it sends that value right back to you. This is how we interact with objects, through their public methods.
Just understanding classes and objects, that's a huge first step. It's really the key that unlocks our ability to build much more complex, much more powerful tools. So with this fundamental concept in our back pocket, let's take a quick look at where this journey can take us from here.
This is where it all leads. I mean, once you know how to build your own custom objects, you can start organizing them into these incredibly powerful structures. You can build simple things like lists, or more specialized tools like stacks and queues. You could build complex branching trees that are amazing for fast searching, and even create graphs to model entire networks, like a roadmap or your social connections. Each one of these is like an awesome new destination on our learning adventure.
So we end with this. These concepts, they are not just theory for a test. They are the real, fundamental building blocks for creating actual software. Learning about classes and objects isn't just about an academic exercise. It's about getting your hands on the most powerful set of Legos you can possibly imagine. So the real question is, what are you going to build with them?